Hello, and thanks for using TickBoom. In this video, I want to revisit this question 16a part 1 specifically, which was sent through to me a few months ago, and at the time I did work through a possible answer to this. I came up with a certain approach that could prove the inequality we were asked to show. But in the back of my mind, I kind of had this suspicion that the technique I used wasn't really the one that the question writers intended. And I did put a little bit of a call out to people saying, if you have a better way to do this, please let me know. And I did. I had a few students get in touch with me pointing out that actually there is an alternative way to do this part 1, which is more in line with what the question writers wanted us to do. So what I'd like to do now is point out that solution. So firstly, thank you to those students who got in touch and reached out to me. It was very helpful to get your input on this. I've had on my to-do list for quite a while now to actually work through this, but it's only now that school holidays have kicked off and the rate of questions I've been getting has slowed down a bit that I've actually been able to get on top of my to-do list. So now I'll work through it. In case you don't remember, the question says, consider the graph of the function y equals e to the x. By considering areas, show that if n is a positive integer, then 1 on n must be less than e to the 1 on n minus 1, which must be less than e to the 1 on n. Alright, so I'll just write out what we're being asked to show. So we want to show that 1 on n is less than e to the 1 on n minus 1, which is less than e to the 1 on n, for n being a positive integer, so basically n greater than 1. Now the first thing we can point out that is if n is greater than 1, then 1 on n must be less than 1, just by taking the inversion of each side and reversing the inequality. So that's what we're dealing with. So the first thing to do is to, do what the question writer said and consider the chart of y is equal to e to the x. And in my original solution, I kind of didn't really do this. I looked at a chart of a kind of derivation, a slightly different thing, not e to the x in its pure form. But in this version, we do exactly what the question writer says, which is to just plot up y is equal e to the x to start with. And one thing we can say is we know it will intercept it at 1. And what I might do now is I might plot on just an arbitrary point that I'll call 1 on n, so at x of 1 on n, which we know will be less than the point 1. So if this is x is equal to 1 here, then I'm picking a 1 on n that's above 0 but less than 1. Now if I kind of then go, well, where does that 1 on n intersect with our y equals e to the x? The y value there would simply be e to the 1 on n. Another thing worth pointing out here in the chart is that if I just draw this horizontal curve of y is equal to 1, what we can see by comparing areas, and that's what the question asks us to do, by comparing areas, show this inequality. So again, this is definitely more in line with what we were asked. I might just use some colours here. This area of this rectangle here, which I'll shade red, we can see that between 0 and 1 on n, that area is always less than the area under the curve y equals e to the x, which I'll just shade here with my black pen. And we can see that area between 0 and 1 on n is always less than the area under this rectangle, which I'll just use green. And so by considering these 3 areas, I think we can get to this inequality with 3 components to it. Because what I'll do is I'll just write it up as, we know the red area is less than the black area, which is less than the green area. So if we can work out what each of these areas is, I think we'll get to our inequality. So if I start with the red area is simply the area of a rectangle, which will be the width and the height of that rectangle. So here we see the width is 1 on n, and the height is 1. So the red area is simply 1 on n, which is good news because that's one part of the inequality. If I look at the black area, that is the area under this curve y is equal to e to the x between 0 and 1 on n. So we can evaluate that using integrals. So we can go the integral between 0 and 1 on n of e to the x dx. That would give us that area. The integral of e to the x is simply e to the x between 0 and 1 on n. So we can write that as e to the 1 on n minus e to the 0. Anything to the power of 0 is 1, so that gets us e to the 1 on n minus 1. That's also good news because that's this bit here. Finally, we'll do the green area. I might have to turn over for this. But the green area is just another rectangle. And so in that case, the width here will be 1 on n once again. But the height will be e to the 1 on n. So that's simply e to the 1 on n, and that's also good because that's this bit here. So now I can just combine them. I can say, therefore, the red area, 1 on n, is less than the black area, e to the 1 on n minus 1, which is less than the green area, e to the 1 on n. And we see that that is the inequality we were asked to show. So that is the proof right there. So if you compare this approach to the approach I took, whilst we both got to the same place, this is clearly a more elegant way to tackle it, and definitely in line with what the question writers intended, because we've done exactly what they asked. We looked at y equals e to the x, we considered areas, and we got exactly where we needed to be without too much fuss. So thank you once again to those students who paid heed to my call and pointed out the better approach that I was certain existed, and at the time I just couldn't really think of it myself. So hopefully now that you've seen this, you could, if you encounter a similar question, use a similar technique to kind of get there, this kind of approach of considering areas. So hopefully you found this helpful, and tick boom.